All right, guys, in these two problems, it's asking us, it says given a polynomial f of x and a factor of f of x, okay, right here we have a factor. We want to factor f of x completely. Okay, so how we're going to do this is we're going to take our function, first off solve for x and then use that with a little synthetic division and then hopefully factor afterwards. So let's see if that works. So in this one, if I solve for x, x is going to equal 2, which means if I put a 2 on the outside of my synthetic division using 1, 2, -5, -6, this should give me a 0 at the end, and I can take whatever's left over and factor that more. Okay, let's try it. 1 comes down, that's 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. -5 plus 8 is 3. 3 times 2 is 6. -6 minus 6, or -6 plus 6 is 0. That's good. Okay, we got this, so that means that 2 is a factor. All right, then I can take what's left over. Remember, this is my constant, linear, and quadratic term. So we have x squared plus 4x plus 3, which factors nicely into x plus 3, x plus 1. And then also my factor from up above here, what I divided by x, or I'm sorry, not the 2, but the factor itself, x minus 2 times 2, would be completing that factorization. Okay? Now let's try one that's x to the 4th to start with. Okay? So in this problem, if I write these out, we have 1, 1, -16, -4, 48. Okay, and on the outside of my synthetic division on this problem, we're going to use -4, because if I solve x plus 4 equals 0 for x, x is going to equal a -4. Okay, bring down my 1. That's going to be 1. 1 times -4 is -4. 1 minus 4 is -3. -3 times -4 is positive 12. 16 plus 12 is 4, -4. -4 times -4 is a positive 16. -4 plus 16 is positive 12. 12 times a -4 is a -48. Again, that's good because it equals 0, showing that this is a factor of it. And then let's see what we have left. Again, we have our constant, linear, quadratic, and cubic term. So this would be x to the 3rd minus 3x squared minus 4x plus 12. And these are going to equal 0 because we want to factor them. Or I'm sorry, we're not solving, we're just factoring. It's not equal 0. But we're going to solve this by grouping, factor by grouping. Take out an x squared, leave me with x minus 3. And if I want x minus 3 over here, I have to take out a -4. Leave me again with x minus 3. So what I have left over is x squared minus 4. In this one we have x minus 3. And when I do this, let's see, x squared minus 4 is a difference of squares, giving me x plus 2, x minus 2. X plus 2, x minus 2, x minus 3. And then from up above, we have our factor of x plus 4. Okay? If I were to set these equal to 0, we would have 4 solutions, which is good, right? -2, +2, +3, and -4. That's x plus 4, if you can't read that. I can't read that. X plus 4. So we have 4 solutions. That's good because our degree is 4, so we have to have 4 roots. Okay, and so that's how you factor it. Eventually, we're going to set this equal to 0 and solve for each of those. We have 4 solutions.